Module 9, the Peripheral Nervous System. Introduction. The peripheral nervous system encompasses sending signals to and from the muscles of our body, as well as sensory signals like temperature and light and chemicals, how we feel inside our bodies, orientation, all those things to help us know what's going on around us. As I'm swinging on this swing set, my peripheral nervous system is working hard to know which muscles to use and how to maintain my balance so I don't fall off the swing. As we begin to learn more about the peripheral nervous system, you should begin to understand how our bodies take in information from the world around us and interpret that information to best help us as we move and live. The peripheral nervous system can be divided into two sections: the efferent division, sending signals to the effectors, the muscles and glands, that cause an effect, and the afferent division, sending signals away from the receptors back to the central nervous system. You've already learned about these two divisions, but now we're going to go over them in more depth. The efferent division of the peripheral nervous system can be further divided into two systems: the somatic motor nervous system and the autonomic nervous system. The major differences between these two groups has to do with the effectors that they control. The somatic motor nervous system controls the skeletal muscles, and the autonomic nervous system controls smooth muscle, cardiac muscle, and glands. Make a fist. Now open your hand. You did those movements because you intentionally made the effort to contract and relax your hand muscles. Your skeletal muscles are voluntary muscles, meaning that you can make them move when you want. The somatic motor nervous system, then, can be voluntarily controlled. The autonomic nervous system is involuntary. It is self-controlling, hence the prefix auto. And it can be affected by conscious thought, such as when you decide to think about a stressful subject and your heart rate increases a bit, or if you think about a relaxing subject and your heart rate calms down a bit. But the autonomic nervous system cannot be directly controlled by conscious thought. Anatomically, the somatic motor nervous system and the autonomic nervous system differ as well. For the somatic system, there is only one neuron with its cell body located in the central nervous system and extending out to the effector. In the autonomic system, there are two neurons going from the central nervous system to the effector: the preganglionic neuron and the postganglionic neuron. The cell body of the preganglionic neuron is found in the central nervous system, either in the spinal cord or the brainstem. You can see it here. The axon extends out and synapses with the postganglionic neuron at an autonomic ganglion. A ganglion is composed of the cell bodies of neurons that are outside the central nervous system. That is why one neuron is preganglionic and the other is postganglionic. There's a ganglion between them. The postganglionic neuron's cell body is in the autonomic ganglion, extending its axon to the effector. Another difference between the somatic and autonomic systems is the appearance of the neurons. Somatic motor nervous system neurons have myelinated axons. In the autonomic nervous system, the preganglionic neuron's axon is myelinated, but the postganglionic neuron's axon isn't. Additionally, the somatic system uses only acetylcholine as its neurotransmitter in the neuromuscular junction. In the autonomic system, the preganglionic neurons use acetylcholine, but some postganglionic neurons use norepinephrine as their neurotransmitter to their effector organs. Well, we've compared the two systems' controls, anatomy, neuron appearance, neurotransmitters, and lastly, we can say that the response from the effectors of these two systems is different too. The somatic system is an excitatory system, existing only to excite their effectors, your skeletal muscles, when acetylcholine is released at the neuromuscular synapse. However, response from the effectors of the autonomic system can be excitatory or inhibitory. Some neurons can excite smooth muscles to work, such as when your stomach becomes full of food and it needs to digest it. Yet other neurons of the autonomic system inhibit stomach muscles when you are doing something strenuous, like exercising.